All right, so in this video we are getting ready to take a retake test on the Unit 5, sections 6 through 8. So this is the second part of Unit 5. And the first two problems were asked to use the properties to, in the first one, expand our logarithm into a set of terms involving the same log. All right, so since I'm multiplying the numbers that are on the top, I'm going to have log of 3 and I have log of a squared. And then because I'm dividing by b to the third and c squared, both of these are on the denominator of this fraction, so that means I'm dividing both of them. I am going to use subtraction here, and I'm going to make this into two different logs using subtraction. So I have minus a log of b to the third, and then I also have minus a log of c squared. The other property that I'm going to put into play here is anytime you have an exponent in a log sentence, you can bring the exponent out into the front and actually multiply that log by whatever the exponent is. So in log 3, I'm just going to leave this as log 3. And then this is 2 log A minus 3 log B, log of B, that's messy, sorry, and then minus 2 log C. Okay, so this is the expanded version of this logarithm with lots of factors inside of it. In part 2, we're going the other way. All of these have base of ln. All right, so I'm finding the natural log, actually all of these are base e. When I have a natural log, that means I have a base of e. So I have an a plus 4, an a plus 1, and this minus 3, the 3 actually can become an exponent, and the minus means to divide. So I'm going to have 1 log. So natural log, I know it's base e. The a plus 4 plus a plus 1 becomes multiplication. A plus 4 times a plus 1. And then the division, because of the subtraction, I'm going to have a minus 1, and that's to the third power. In part 3, it's asking us to find the domain of the following functions. So in this first part, we just need to remember that we can only do logs of positive numbers. So this part in the log has to be greater than 0. So for this part that I'm taking the log of, which is x plus 4, has to be greater than 0. So x has to be greater than negative 4. So this is my domain. All right, next one. Same thing. I have to have a log of a positive number. So x minus 7 has to be greater than 0. If I add 7, x has to be greater than 7. This is my domain. Okay? These other pieces, the add 3 and the negative, are just shifts and flips, and that doesn't affect my domain. But if I have anything that's less than 7, like if I have a 4 here, 4 minus 7 would be negative 3, and I can't do a log of negative 3, so that's not in my domain. Part C is an exponential equation, and if we remember any number like 2 to the x, we had a domain of all real numbers. I can put anything I want here. I could put a positive value and my answer will be very large. If I put a negative value in for x, I would end up with a fraction. I can put in 0 and I would get 1. So I can put any value in there for x. Now if we remember, e is just a constant value. Remember that's like 2.71. So that's just a little bit bigger than 2. So any number I put for x here, I'm going to have a large number or a fraction or 1 if I put in a 0 here. So it doesn't matter what I put in. My domain for this one is going to be all real numbers. Okay. Now we're going to be solving some equations. In our equations, we have to use the properties when we can. So if I notice here, I have 2 log terms. My log base here is 10. Now I can write this as a single logarithm. So if I can do that, that's what I'm going to do first. So this is going to become log, and it's base 10, of x times x plus 15. And that equals 2. And it's times because we're adding 2 terms together, and when we think about the 2 terms with the same base, that means I can put them together using multiplication. Now I'm going to write my exponential sentence. So I'm going to take 10, square it, and that has to equal what's inside here. So I'm going to have 10 to the second power equals x squared plus 15x. Now this is a quadratic equation, so I know 10 squared is 100, and if I put this into standard form for a quadratic equation, I'm going to subtract 100. X squared plus 15x minus 100, and I'll factor this, and 20 times 5, if I subtract them I get 15, so I have a plus 20 and an x minus 5. That would give me negative 100. Add them together, I get plus 15. So if each term I set equal to 0, x is negative 20 and x is 5. But I also have to keep in mind that it has to work inside my domain. So if I look back here, I have to have a log of a positive number. So if I plug in negative 20 here, I don't have a positive number. I can't take log of negative 20. So log of negative 20 is an extraneous value. But log of 5 will work. I can do log of 5 and I can do log of 20, but I can't do a log of a negative number. So my only solution in this case is x equals 5. In number 4, on this side I have a single logarithm, so I don't have to put them together like I did in the previous problem. So I can just go ahead and write my exponential sentence. So this is telling me I have 3 to the second power equals 3x minus 1. 3 to the second power is 9. That equals 3x minus 1. If I add 1 to both sides, 10 is 3x. And if I divide by 3, x is 10/3. Number 5. This time I have multiple terms, which I can write as a single logarithm. Because I'm subtracting down here, I'm going to write these x plus 1 and x as division. So I have the natural log of x plus 1 over x equals 2. So now I'm going to write the exponential sentence of this. Now, remember, if I have a natural log, my base is e. So I'm going to have e squared equals x plus 1 over x. All right, so what I want to do is solve for x here. So I need to get rid of my fraction, and if I multiply both sides by x, my x's will cancel on this side. So I have x times e squared equals x plus 1. Now, to get x by itself, I need to put the x terms on the same side. And to do that, I'll subtract x. So I have x times e squared minus x equals 1. And now I'm going to factor out an x. So I have x times e squared minus 1. If I do the distributive property, I would get back to this. Now this equals 1. And to get x by itself, I'm going to divide both sides by e squared minus 1. So x is 1 over e squared minus 1. In problem 6, this time I have a log of something equals 1 plus a log of something. So to be able to write a single logarithm, let's take this term and subtract it to the other side. So I'll have log of 2x plus 1 minus log of x minus 2. I move this over, and that's going to equal 1. Now I'm able to write a single logarithm. I have subtraction, so this is going to be a division problem. Log of 2x plus 1 over x minus 2 equals 1. Now my base here is 10, and I need to know that to write the exponential sentence. So I'm going to do 10 to the first power equals this fraction. So 10 to the first power is just 10 equals 2x plus 1 over x minus 2. All right, so now just the algebra. I'll multiply both sides by x minus 2. So I have 10x minus 20 equals 2x plus 1. If I subtract 2x, I'm going to get 8x, and I'm going to add 20 to this side, and that will equal 21. And x will equal, if I divide both sides by 8, 21 over 8. Sorry, that's squeezed in there a little bit. All right, looking on the next side, I have two more equations. Number 7, now notice I have a trinomial. I'm going to write this darker so I can see this a little bit better. All right, same problem. I just couldn't see right in here. So notice that I have a 2 to the x power, and over here I have a 2 to the x power, and I can write this a little bit differently. This is the same thing as 2 to the x squared minus 2 to the x minus 12 is 0. So if I want to solve for x, but let's do some substitution. And we're going to say let v equals 2 to the x power. So in that case, wherever I see a 2 to the x, I'm going to substitute a v. So this is going to be v squared minus v minus 12 is 0. And I can factor this. This would be v minus 4 and v plus 3. So v is 4 and negative 3. Now, if v is 4 and I plug it back in here, so if I substitute in the beginning, I need to substitute back. So I'm going to plug in 4 for v, and if 4 is 2 to the x power, then x must be 2 because 2 squared is 4. Now I'm going to take negative 3 and substitute that back in for v. Negative 3 equals 2 to the x power. And this is one of those where if I have 2 to the x power, I have to have a positive value. Okay, and if I think about the graph of 2 to the x, it's going to look something like this. Always positive. I'll never get a negative 3 down here. So this part is extraneous. So my only solution is x equals 2. Next one, 3 to the x is 14. All right, so here I already have an exponential sentence, but I have a variable in the exponent. So to get the variable out of the exponent, I need to log both sides. So I have log of 3 to the x power equals log of 14. Okay, we're not going to come out with a very nice pretty number here. Using my properties, I can take x and bring it out to the side. So I have x, this is how I get it out of the exponent, times log of 3 equals log of 14. And that could have been log or natural log. It doesn't matter if you use log base 10 or natural log base e. You're going to get the same answer. All right. To get x by itself, I need to log 3 divide by log 3 on both sides. So x is log 14 over log 3. Now, if I want to get an approximate value for that, I can use my calculator. And I'm going to zoom in a bit here. So if I do log 14, and I'm closing my parentheses here, divided by log 3, close the parentheses, I get 2.40217. Now I just want to show you, if I use natural log of 14 divided by natural log of 3, I'm going to get the same value. So again, it doesn't matter which one. It does, oops, it doesn't say here, but generally we will round to the 3 decimal places when we're working with logs. So this will be 2.402 approximately, and that is the value. So in the next set of problems, we are working with applications. So in the first few, we're looking at interest. And in number 9, it asks us to find if we have $1,000 invested at 5.5% compounded monthly, how much is in there in the account after 2 years. Well, if we remember our formula, we have A equals the principal times 1 plus R over N to the NT power. And if I identify my variables in this information, $1,000 is invested, so that's my principal. The rate is 5.5%, which in a calculator I have to move the decimal place over 2 spots. So I have 0.055. Compounded monthly, that means my N value is 12 because it's going to be compounded 12 times during the year. How much is there? That's my amount after 2 years, which is my time. So I'm finding the amount, and if I plug in the values I have here, my principal is 1,000 times 1 plus my rate is 0.055 divided by 12 to the N, which is 12 times T, which is 2. Those are both in the exponent. So if I look at my calculator again, and you can put this all in the calculator, and in some cases I've noticed that some people like to do this and then round. Do not round until the end. Okay, if you round in here and then you try to apply an exponent, what you rounded, your difference is exponentially off. So let's take what we have here, which is 1,000, and I'm putting parentheses, and I have 1 plus 0.055 divided by 12, closing the parentheses, and then I'm going to multiply that to the power of 12 times 2, which is 24, and I can multiply that together, or I can do 12 times 2, but there wasn't any rounding here. When I press equals, I get 1115.9975. All right, so A is 1115.9975. However, and I want to point this out, it does say in the directions, round your final answers to 2 decimal places. All right, now here we do that because it's money, and we only have money that's represented 2 numbers after the decimals, that's pennies. So my answer is 1156.00. All right, $1,116. In Part B, it says you want to have $500 in your savings account after 2 years. So this is the amount that you want when your time is 2 years. How much do you need to put in the account? That's my principal that pays 6%, so my rate is 0.06, compounded quarterly, so N is 4. So I'm trying to find out P here. So if I use this same formula, I have A equals P times 1 plus R divided by N to the NT power. And if I plug in what I know, I'm going to have my A value be 500. That's not equal. There we go. 500 equals P, which is what I want to find out, times 1 plus my rate is 0.06 divided by N, which is 4, to the N times T power. And my T is 2 and my N is 4, so altogether this is 8. But if I put this in the calculator, actually what I want to find is P, so I have to divide both sides by all of this. So I'm going to divide 500 divided by 1 plus 0.06 divided by 4 to the 8th power. Now I can put this in my calculator. And This is what it looks like. I'm going to take 500 and divide by. I need parentheses. All of this I'm dividing by. So I have 1 plus 0.06 divided by 4. And this is to the 8th power. So I'm going to put to the 8th power. Now this 8th power is applied to just the part that's on the denominator. All right, so when I press enter, I get $443.86. Now, thinking about this in terms of is this reasonable, I'm going to start with $443.86, and after 2 years with adding some interest to it, I'll end up with 500. If you get a number that's bigger than 500, that's not a reasonable answer. In part C, it's asking how long does it take to double your money? So how long does it take? That's my time. To double your money, so I'm going to double my money, which is twice the principal. If you can invest it at 3%, 0.03 is my rate, compounded continuously. Now when I'm compounding continuously, I'm not going to use this formula. My formula for continuously compounded interest is A equals P times e to the RT power. So in this case, it doesn't matter how much money I start with, I'm going to end up with twice that amount. So I'm going to have 2 times whatever I start with equals P, the amount that I start with, times e to the 0.03, and I'm finding t. Looks like we have a lot of variables here. But the p's, if I divide both sides by p, those are going to cancel out. And now I just have 2 equals e to the 0.03 t. My variable now that I'm finding is the time. It's in the exponent, so I need to natural log both sides. So from this, I'll have ln2 equals ln of e to the 0.03 t. So I can bring this out in front, 0.03 t. And ln of e is just 1. So that just kind of cancels out. So 0.03 t is equal to ln of 2. I'll divide by 0.03 on both sides. So my time that it takes to double is ln of 2. So I find ln 2 and divide it by 0.03. Notice I closed my parentheses here when I did that. Otherwise, you're doing ln of 2 divided by 0.03 and taking the natural log of 2 divided by 0.03. So be sure to close your parentheses. And when I press enter, I get 23.10 years. So t is 23.10 years. On number 10, here we have a culture of bacteria that obeys the law of uninhibited growth. So that means we're going to use the formula just like this formula right here, where we have a number of bacteria, but we start with an initial amount times e to the k, which is a rate, times t, which is time. Okay. Same formula, just different variables. So it says a culture of bacteria obeys the law of uninhibited growth. That's the formula. We have 500 bacteria are present initially. Well, part A says what is the initial amount of bacteria? 500. So this is my n sub 0 value, initial number of bacteria. Now there's 700, which is my final number after 1 hour. That's my time. We want to find the growth rate. So if I use this formula, I'm going to end up with 700 equals, I'm going to start with 500 times e to the k times t. After 1 hour, I have 700. What's the rate of growth? So here I got to divide both sides by 500. So I have, I'm going to go over here, I have 7 over 5 equals e to the k times 1. Now to find k, I need to do the natural log of both sides. So ln of 7 divided by 5 equals ln of e to the k, which is just k. So to find k, I'm going to do ln of 7 divided by 5, close parentheses and press enter, and I get 0.3364. So k is 0.3364. Now here it's important that we follow the directions, and we're going to round our answer to 2 decimal places. So if I round to 2 numbers, that 6 makes the 3 go up, so I have 0.34. If I use 0.336, my answer is going to change a lot because this 6 is going up into an exponent, and it's going to make a big difference in our answer. Part C says how many will be present in the culture after 5 hours. So I want to know the final number. I still am starting with 500 bacteria times E. My K value is 0.34 times 5. So I'm just calculating this. On my calculator, I have 500 times E. So on a decimal, you could just go to the alphabet and find E, to the power of 0.34 times 5. Okay. So zooming in here, I have 0.34 times 5, all of that in the exponent. Okay. And when I press enter, I get 2736.97, and I don't need to round it up. So how many do I have? 2736.97 bacteria. And the last question will ask us, how long does it take until there are 30,000 bacteria? So this is my final number, 30,000, equals my initial number is still 500 times E to the K, which is 0.34, times T, and in this case I'm finding T. So first I'll divide 30,000 divided by 500, and I get 60. Times e to the 0.34t. Now I need to natural log both sides to get the exponent, the variable out of the exponent. So natural log. So I have ln, sorry, you can't see that, of 60 equals 0.34t. Move the exponent over. Ln of e is just 1. Now I'm going to divide by 0.34. So ln of 60, close parentheses, divide by 0.34. 12.04 years. And there we have it. All right. Good luck on your retake.